Hello everyone, good evening. So my name is Jihar Gifari. As mentioned, I'm a data scientist and I'm also running my own AI solution company called Aldrun Group. So tonight we're going to talk about something that sits in the intersection of data science, business strategy, and a problem with hundreds of £1,000,000, which is marketing mix modeling. Can you raise your hand if you at least familiar with what is marketing mix modeling in general? Okay, I have one person. All right. Can you raise your hand again, the only one person, if you have technical experience building marketing mix modeling before? Right. Okay, so today we're going to talk about marketing mix modeling specifically with Google Meridian. Let's jump right in. Here's a quote from over 130 years ago. An American pioneer of modern advertising, John Wanamaker, once said, "Half the money I spend on advertising is wasted. The problem is, I don't know which half." So marketing measurement problem is not something that we experience nowadays. It's been there for literally centuries, over 130 years ago. And now you'd probably think, with today's technology, this kind of problem should be obsolete by now, should be solved. I mean, we have machine learning, deep learning, AI agents, we have all the fancy technology. So should be easy peasy, isn't it? Well, let's see what happened in less than just 10 years ago. This is a story from Uber. The head of marketing performance once found in 2017 that their ads was shown to a website that they're already blacklisted. So what they did, they tried to turn off a few ads budget. At first, they only turned off 10%. And then the marketing manager didn't see any impact on driver acquisition or rider acquisition. The number of app installed remained the same. So he turning off more and more budget, to a point until he turned off the whole $100 million. And surprisingly, zero impact on rider acquisition. So apparently the paid installs just simply flipped to organic installs and the total number didn't change. So what happened, there's an ad networks that were claiming credit for downloads that would have happened anyway, the organic credit. So this is something called attribution fraud. And Uber eventually tried to sue more than 100 ad network. This is just one case. There's another case with B&G. In the same year, they cut $200 million in digital ad spend, and they actually increased the reach by 10%. They tried to reinvest that to other platforms like TV, audio, e-commerce, better results for less money. So this is just an example of that 100 years old problem is actually not just still alive, not just irrelevant, it might even got worse. And every company that is currently doing marketing might also experience this. And if you're working with data, learning MMM, you might be the one who contribute to solve it for your company. So the next question is, why is this still a problem? Well, the problem is very complicated, of course. But I'm just going to highlight a few events that is happening over the past few years. Let's zoom in 2018. It's mentioned before, there's GDPR and CCPA. The open secret of the advertising industry that it is built on exploiting user data, right? Until 2018, the GDPR in the EU and UK requires opt-in consent from the user before any tracking. So there is no more tracking by default. And then the similar stuff happened in USA by CCPA, the California Consumer Privacy Act, that gives the user right to say, do not sell my personal information. So for the first time, companies can be fined billions for misusing personal data, in theory, right? But that's at least a progress. In 2021, Apple launched iOS 14.5 with something called ATT, which is App Tracking Transparency. You know, that little pop-up that says, ask app not to track. That small pop-up apparently bring a massive impact in the entire advertising industry. Even Facebook says it will result in 10 billion revenue hit in that year alone. And apparently what happened actually, in just one day, Facebook stock dropped 26%, which equivalent to 230 billion loss gone in one day. And on the other hand, some browsers like Safari and Firefox already blocking third-party cookies by default. Why is this relevant? Why I'm talking about ATT and cookie deprecation and GDPR and CCPA? Because marketing measurement at that time was relying on an approach that is called digital attribution or multi-touch attribution. So basically when you click an ads on Google on Monday, and then you click an ads on Facebook on Tuesday, and then you bought the product on Thursday, last touch attribution will say, oh, it's because of the last ads that you click. In multi-touch attribution, they will use machine learning to find the combination between the two. So the marketing measurement was relying on digital attribution, but digital attribution required cookies. It requires device ID. It requires user-level data. That because of all of this, it is really restricted, if not disappeared. So the whole marketing measurement that people are relying on are now basically and fundamentally broken. With multi-touch attribution or the attribution model, you used to be able to analyze cross-platform data. So you could analyze if a user click Google and then click another ads from Meta, click another ads from other platform. You could do that, but with the restriction, it's all separated. That's what it called as walled garden. So you need to analyze it separately. And when you analyze it separately, each platform tends to overcredit themselves. Like Google will say, oh, this conversion is because of me. And Meta will say the same as well, right? So that's another problem with attribution or digital attribution. The other problem, the name itself is digital attribution. So it doesn't really work with offline channel like TV, radio, out of home, which a lot of brands still use. And then even if it's measuring the attribution of various digital channel, it only measures correlation, not causation. Like just because you click an ads 2 days before you buy something doesn't mean that you buy that because of that ads, right? So it's just a correlation, not causation. So basically the whole trend that is happening over the past 5 years sets a stage for an alternative solution for marketing measurement. And that's where MMM comes into play. That's why people in the internet now say MMM Renaissance, because MMM is not something new. The old technique from 1960s is now coming back, but now with stronger solution. Many companies are building it. Facebook and Google also building it. That's why we have Google Meridian now. And if you look at the Google Trends, I try to look, the keyword here is actually marketing mix modeling. The red one is multi-touch attribution, which is the attribution model. And then Google Meridian. You can see the red line is multi-touch attribution, it's flat. But for marketing mix modeling and Google Meridian, it has like a significant jump over the past year. This is a living proof that MMM is something that everyone is currently looking as an alternative solution for marketing measurement. Even there is a survey says 60% of US advertisers already using MMM. The rest, the 58% of the rest considering to use it. And it's still improving until now. Even just last week, literally last week, Google just released the no-code tools for marketing mix modeling. It's still in a beta version. It's just a pre-coded Google Colab. In just no time, they can build a whole software for it. So this is something that is really, really new. And that's something that we're going to learn today. So what is it actually, marketing mix modeling? So in the simplest term, it's just a statistical models that takes your business outcomes, like your revenue or sales or conversion, whatever your KPI is, and decomposes it. It tries to separate what comes naturally from what comes because of your marketing, right? So for example, if your KPI is sales, the equation is like this. So sales equals baseline, it's like your branding or seasonality, basically the demand that exists even if you stop all advertising tomorrow. This is like your natural KPI, like your natural sales. And then you add the sum of media contribution, TV, search, social, whatever marketing activity that you run. And then you add controls, which is the external variable that impacting your KPI, impacting your sales, but it is out of your control, like economic factor or weather, basically every external factor that influence your KPI. And then there's noise. This model, the marketing mix modeling, is basically try to answer 3 core questions that is often asked by CMO or marketing director or data scientist or data analyst that is working in marketing. The first one is, what is driving my results? What channel contributing to my sales? What channel is contributing to my revenue? That's the first one. The second one, what is the ROI of each channel? I spend money on a certain channel. What is the return on that money, right? We tend to want to measure everything that we spend, right? And then the third question, arguably the most important one, is how should I allocate budget in the next quarter or the next period? The first 2 questions is more about retrospective analysis, like a backward-looking analysis. The third one is more of a forward-looking analysis, like a predictive analysis. So this is arguably more important. Before we see how Meridian in action, there are a few concepts that is important to understand. Maybe I'm not going to dive very deep into this, and this is just a few of them. The first one is the concept of base versus incremental. When you see the result from marketing mix modeling, this is a typical one of the results of marketing mix modeling, where you see a baseline. This purple area is the baseline, which is like the natural income that you will get without the marketing activities, right? So this is the week, the time series by week, and then the KPI here is conversion. It can be revenue, it can be sales or whatever, right? And if you see the white dashed line, it is the actual conversion that you have. And between the white line and the purple line, there is a few colors there. That is your marketing activities. So you can see the contribution of each channel in different time, right? So the purple color, we call it the base. And the various color is the incremental KPI or the incremental revenue or the incremental sales because of your marketing. Because of the channel A. Channel A could be Google PMax or Google Ads or Google Shopping. And channel B could be Meta ads or TikTok ads or whatever, right? So that's the first concept, base versus incremental. The other terminology that we need to understand is ad stock or carryover. When you saw ads today, doesn't necessarily mean you will buy something tomorrow, right? There is something like a lag effect. So advertising doesn't stop working the moment the ad ends. Like a TV spot aired on Monday still influence purchase on Tuesday, Wednesday, and beyond. There is a lingering effect called ad stock or carryover. The analogy is like a ringing a bell. When you make a sound with the bell, it has a sound which is the impact. It is loudest at first, but from time to time it decays. So that's the analogy. So there's a decay rate. Lower decay rate means no carryover. High decay rate means heavy carryover, and so on and so forth. And another terminology is saturation. In economics, we call it diminishing returns. So if you haven't like eating for a while, or if you're fasting and you take a sip of water, it's very refreshing, right? But after the 20th sip of water, it's not that refreshing anymore. There's a diminishing utility or diminishing return. Same goes with marketing. When you spend £1,000 on a channel, it reached the most eager buyer. And then you spend another £1,000, it reached slightly less eager buyer. And eventually, if you already spend like £100,000, maybe it only reach people that doesn't really care, right? So there is something called saturation. In marketing mix modeling, we try to model this in something called Hill function. Like this is the function. I think we don't really have time to really deep dive into that function. And then the last one is response curve. So if you combine the ad stock and the saturation or the Hill function, you get response curve. So let's say we have two channels, channel A and channel B. Channel A could be Meta ads, channel B could be Google ads. So channel A is the green one, channel B is the orange one. We can see that, and the dot is our current spend on that channel. So we can see that we are spending more on channel A instead of channel B. So in general, if we don't know anything about it, we might think, well, let's increase the spend on channel B because we spend less on that, right? But channel B is actually saturated. If you add more spend, the incremental conversion is not going to be significant, right? Because it's already saturated. So this is where response curve is very beneficial. And then there is something called marginal ROI. That's basically the return on the next dollar spent. Right, so this is the last concept I need to explain before we dive deeper into the Meridian, which is Bayesian. I'm not sure how many of you there are data technically that understand the basic statistics, but there is something called Bayesian approach and frequentist approach in statistics. So usually the most common approach that is taught in typical statistic course is frequentist approach. So we need to understand that most MMM frameworks use Bayesian approach. So it's a different paradigm, it's a different mindset. So what differentiates frequentist and Bayesian? The difference is how we treat parameters. And what it means by parameters is the variable that we try to estimate. Right? The typical example that we use in the course, usually like, what is the average salary of data scientists in London, right? So you gather a sample data and you make an estimate, right? And in a frequentist approach, you would say, oh, the average salary of data scientists in London is between 70 to 80K a year with 95% confidence interval. So that 95 confidence interval doesn't really mean that there is a 95% chance the average salary would be in that range. That's not what it means in frequentist approach. In frequentist approach, a 95% confidence interval basically means if we do the experiment, if we repeat it 100 times, 95% of the interval will contain the actual average salary. And what is the actual average salary? We never know. Because in frequentist, we treat parameter as fixed unknown value. We don't know it, right? So that's what it means by 95% confidence in frequentist. In Bayesian approach, we treat parameters as probability distribution. And therefore, when we say the average salary of data scientists is between 70 to 80, with 95% confidence interval, it actually means there is the probability of average data scientist salary is between that range. So this is particularly important because when, let's say, a CMO asks, what is the probability of my TV ROI above 2? We can answer that only with Bayesian properly. We cannot really answer that with frequentist. That's why most frameworks for MMM is using Bayesian approach rather than frequentist approach, including Google Meridian. Another framework is PyMC or Orbit. It's also another MMM frameworks, and Robin using frequentist, and Robin is built by Meta. Right, so how is Meridian actually answer the core 3 question that I mentioned previously? These are the few core results. I think I'm just gonna skip this because I will re-explain it anyway in the code. So yeah, I think let's just, there should be a QR code right there, but I don't see any of you open a laptop anyway, so I don't think, okay. So this is a QR code. If you want to scan it, it will take you to a Google Colab with a full instruction how to do marketing mix modeling. So you can scan it if you want. It will take us to this. I will share the slides after this anyway. So I already run this because to run marketing mix modeling, it uses TensorFlow and it needs GPU, so it takes about at least 15 to 20 minutes. So we're not going to run that now. So this has like the complete, I think we need to kind of, I'm just gonna skim through it. So it has like all the explanation, like what is marketing mix modeling, blah, 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 the advantage of Bayesian. So one of the advantage of Bayesian is that you can encode domain knowledge into something called prior expectation. So let's say if you have a very limited data and you have been working in that specific area for years, you know that, let's say, the ROI for TV channel is not going to be more than 5 times, right? So you can put that into the model, right, as a prior expectation. So therefore, with MMM, in theory, you don't need as much data as if you use the frequentist approach. So that's one of the other. Okay, so not sure why. I think it's because of the internet.
It's not running.
Yeah, it's not. It's
Wi-Fi.
there's Wi-Fi there. WW1 group. Okay, let's just. WW1 group. I didn't see any of it here.
Second one down on the network.
Is it this one? I think so. Okay. Right. Let's just hope that it works. It seems that it is. Let's just try to refresh it. If it doesn't show the output, then we're just going to explain the slides. Okay, it shows the output here. That's great. So this is where I get the visualization there. So let's just move into the load data. In this notebook, we're going to use the data that is officially given by the Google Meridian itself. It is just a simulated data. It has 6,000 rows, 40 regions, so it supports a multi-region with time periods of 156 weeks, which is about 3 years. This is not necessary. This is just EDA, a typical process when you do any kinds of machine learning project, but you don't really need to do it for MMM. It's nice to do it. The important part, I'm just going to walk you through the steps by step for running an MMM, right? So the first one, just like any other machine learning project, you need to do something called data preprocessing, right? In Google Meridian, they have a specific data structure that you need to follow. And in order to build that, you can use the method that they provide, which is the data frame input data builder. So they already have this few parameters, because in this data, the KPI that we use is conversion. It's not revenue, so the KPI type is non-revenue. And the column name here, we have to identify what is the column name. And we need to have a column for revenue per KPI. Okay, so let's go back to how the data looks like, just to see in a glance. So this is the type of data that we need to run Google Google Meridian or marketing mix modeling with Google Meridian. So you need geographical data, time series data, and then impression and span data for each channel. So say you have 4 channel, Google ads, Meta ads, blah, blah, blah. You need to have both impression and spend data for that channel on a weekly basis. And then you have additional variable like promo, conversion, blah, 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 and also population. If you're doing geographical, you need a population variable as well, like the population in each geography. So that's pretty much it. Going back to the first step, which is input the builder. And then we add core component, which is the KPI. And then revenue, population, control. So you can see here, this is a standard, structured way to do it. So it's not like you need to do something smart here. You just basically like plug and play with the data. And then you need to assign role to the variable. So for example, so there are 4 different variable role. The first one is media, second one is non-media, the third one is organic media, and the fourth one is control. So you need to identify which variable are media, which variable are non-media, organic, and control. To give you a highlight, media is basically the channel that you want to measure its ROI. So if you're spending ads budget on a certain channel, that's media, that's paid media. So in this case, it's channel 1, channel 0, 1, 2, 3, 4. And you have both impression and spend data, and you add that as media channel. This is how you add it, just builder dot with media, right? And then for non-media and organic media, so it has an explanation here. Non-media is basically marketing activities as well, but it is not impression based. So you don't have like impression data for that marketing activities. So for example, like discount or promo, the cost of these marketing activities is only materialized if there's an order. Like if you have a discount, you don't spend money on a discount, right? You only spend that money when someone buy, right? So that's non-media. And there's also organic media. So organic media is basically like your unpaid media impression, like SEO, viral, social, and so on and so forth. It's an unpaid organic media. If you have that data, you can use it. If you don't have, just erase this part and just identify the column name, and that's it. That's pretty much it for the data preprocessing. So it's just basically assigning a variable role and making sure the structure is following what the Google Meridian wants. And then the next stage is setting the prior expectation. So I mentioned before that Bayesian approach treats parameter as probability distribution. So when you have a prior expectation of a certain channel, say for a specific channel for Meta ads, I would expect the ROI is between 1.5 to 2.5. Let's say you have that prior expectation. Prior expectation can come from usually 2 sources. First one, if you have run incrementality testing or a lift test before, and you use that result as a reference for a prior expectation, or you simply have a domain expertise in that area. You are very, very expert on that specific field, and you know it's not going anywhere outside that range. You can use that as prior expectation. The problem is the way you insert prior expectation is by using distribution. Did I say something wrong? No. Yeah. This is basically says I expect the prior expectation, the ROI would be around 1.2. So you put 0.2 as a mu and 0.9 as a standard deviation. I already made a code to make it easier to use a business language instead of like a statistic language here. So for example, like this, I expect ROI around X with uncertainty Y, or I think ROI is between X and Y. So you can use this to convert it into a distribution. I'm just going to skip that part. I'm just going to explain the results. So when you run a MMM model with Google Meridian, here's the typical result that you will get. First, you will get the model fit. This is like a typical machine learning, because basically the core model is just a regression, but with a lot of transformation around it. So you still have like a model fit. You have 3 lines here: blue, green, and yellow. The green is not very visible because the green is the actual, blue is the expected. So it aligns very well. The yellow one is the baseline. And this is the contribution. So you can see 77% of the revenue are because of the baseline. So only about 23% something that is contributed by the marketing activity. The biggest one is channel 4 with 6% contribution, and so on and so forth. So this is already answering the first core question from the 3 questions that I mentioned before. This is like just the general contribution. Yellow is the baseline, 23% is all channel. And this is the ROI per channel with the 90% credible interval. So this line showing the 90% credible interval there. And this is like, channel 0 has 1.6 ROI, 1.2, and so on and so forth. This is just another way to visualize it. You can see the revenue and spend, and this is the ROI. You can see this channel 3 has low ROI because it has a high spend but low revenue. That's just an example. It's a bit tough to explain. I think I'm just gonna skip to the some interesting part. So this is the ad stock decay. I think I mentioned previously there's an ad stock, like a lag effect of each channel. And you have prior and posterior. Prior is your assumption before seeing the data. Posterior is the conclusion from the model after taking your prior and looking at the data. The posterior is kind of like the end result or the final conclusion by the model. So in this case, prior is the red one, posterior is the blue one. That's the marginal ROI. So, and just the last one is the budget allocation. So with Google Meridian, you can have something like this. So for example, the overall budget is 220 million. The optimized budget is the same. So with the same budget, you just reallocate it to different channel. From the non-optimized revenue is 258 million. Now the incremental optimized revenue is $265 million, which is 7 million more. So basically, what this does is with the same budget, you can have additional 7 million in revenue over the course of the data here is 3 years. And this is like the recommended budget reallocation. So you should lower down budget for channel 3 and channel 1, and you should increase budget for channel 4, this amount of budget. And this is showing you the current optimized revenue that you have. You would expect less revenue from this channel because you decrease the budget for that channel, but you would expect more revenue in these 3 channels because you increase budget to that channel, and in total you would get 7 million more. That's basically what this chart all about. And this is just the summary. So to finalize, previously you spent 22% on this, you should allocate 28% on this, and so on and so forth. So this is like the most actionable insights from MMM. And this kind of work, just to give you a context, people are paying for this kind of project as a consultancy project. We just do this analysis in Google Colab and wrap it up in a PowerPoint, give a proper presentation, and people are paying like 15K just for like a few months of work to do this kind of stuff. And now it's even easier to run it. But the most valuable thing is to really understand the context, to really understand like the domain expertise, to talk with the marketers, to talk with the business person, so that you don't give like a misleading insights from your analysis. This is the last one. It's just the output result summary. So if you want to get all of that in just one line of code, you can use this. This is from Meridian as well. The summarizer, and then you output models results summary, and you will get everything from model fit and the metrics. You have the R-square, etc. You have the channel contribution, and all the results from Google Meridian. Yeah, and this is just the final response curve. So the recommended budget allocation is done based on this response curve. So you can see different channel has different saturated level. So what it does in Meridian, it tries to find the perfect combination. If you try to increase in certain budget, decrease to another budget, and so on and so forth, until you reach the optimized point, or something called converge. Basically, that's it. That's it. Thank you.